Good morning to one and all. Today we are discussing about soil cement stabilization. Now we are in third chapter. The third chapter is entirely about stabilizations of the soil. In these stabilizations of the soil, we are having a totally 11 stabilization techniques. In those 11 stabilization techniques, in the previous class we discussed about soil stabilization with the help of lime. That means normally lime is a product which is having a chemical content of calcium oxide and a few percent of magnesium oxide as a impurity, so that those two combines with the help of water or any other mechanical parameter and mix it with the soil and gives huge amount of strength compared to a previous soil. So that the lime is normally very cheaply occurring material. Why? Because lime is obtained from limestone. After burning limestone at temperatures 400 to 600 degrees, automatically those limestone will be formed as a lime. Normally pure lime will be in the color of white color. If there is any impurity, automatically those color will be changed to pale yellow. That means normally pure lime is in the color of white color. If there is any impurity, automatically those white color will be changing into a yellow color. Most of the cases the impurity in the lime is magnesium oxide with a small percentages, so that those materials will be gently mixed with the soil's particles and we will get a good quantity of strength compared to the previous cases. But for today's class we have to discuss the stabilization technique with the help of cement content. Normally cement is a different binding material which is moreoverly and mostly using in the world for the construction process. Cement having a major raw materials of calcareous materials, siliceous materials and argillaceous materials, so that whenever these three quantities of materials are burnt at 1400 degrees temperature, automatically they will form as a clinker. Whenever we are cooling those clinkers and grinding, automatically they will form as a powder. Those powder we need to use here, and we have to mix those powder with well grading phenomena. Then after that we have to add some quantity of water to the soil. Then we will get a good quantity of strengthening parameters of the soil. Likely here we are using soil stabilization. First of all, we have to know what is soil stabilization, in which fields it is be better. That means normally we are having different quantities of soils and types of soils. In those types of soils we are having different chemical parameters and physical parameters, so that according to those chemical parameters and physical parameters, for which kind of soil this stabilization should be required and necessary, so that according to their chemical status, that means presence of impurities or presence of ionic matter, we have to consider. So that soil stabilization, in which soil particles are bonded together. That means bonding means automatically there may be a covalent bond or incovalent bond. So that if there is a bond means automatically the strength between two particles will be very high. If there is no bond, automatically strength will be reduced. But in case here we are adding some quantity of cement to the soil, automatically whatever the ionic matter present in the cement, those will be gives bond with the surrounding particles, and those will form as a particles, as forms as a crystals. Automatically those crystals having huge amount of interlocking phenomena. Interlocking means normally one with another, another with another, another with another, they will form as a huge rocky like matters. Whenever rock is having normally high compressive strength, here also the total soil is forming as a rock like matter, so that the soil is getting huge amount of strength whenever we are mixing with this cement content to the soil. automatically we are obtaining huge amount of compressive strength to the soil particles by adding this cement. To achieve a hard and strong bond between the soil particles, cement particles need to coat with material particles. That means normally whenever we are mixing with soil to cement, automatically they will form as a crystals. But in case of getting huge amount of strength, automatically what we have to do is we need to coat particles. Simply what we, in the previous case we are simply mixing lime with the soil content, but in case of here what we have to do is simply we need to spread and coat the cement particles on the layers of the earth. Automatically if there is a spreading and spraying, automatically those will stacked on the surface of the earth. After mixing with some quantity of water, and we have to spray those water on the surface, automatically those bonds will be forming. Calcium silicohydrate gel will be formed automatically. Due to those calcium silicohydrate gel, we will get this compressive strength as early as possible. Normally cement is a setting time is initially 30 minutes, maximum final setting time is 10 hours. Likely initially it will get a strength. To assure a good contact between cement and soil particles, the proper bond and efficient soil stabilization is required. Cement particles must be well mixed with a certain particle size of the soil. Soil cement is generally known as high compact mixture of soil and cement and water. In this particular sentence, what they are simply saying is to assure, that means to ensure a good quantity of strength to the soil particles. Normally if there is a bond, automatically there will be a strength. Like we need to give the bond to the soil particles by simply spraying this chemical part. That means the soil particles with the help of these cement particles, we have to mix with a certain quantities of size of the particles. Normally cement having different fineness properties, so that whenever we are mixing this cement with sand, not sand, when we are mixing this cement with the soil strata, first major point we have to observe is size of the particles. That means here we won't have to consider the size of cement particles, we need to consider the size of soil profile. The soil profile having huge amount of particles, we have to take in a random way and we have to observe what is the average soil particle size, and then we have to confirm it is sufficient or insufficient to mix with the cement. Then only we have to confirm. After those we have to add the cement and we will get the strength. So that we have to observe first and then we have to confirm it is good or bad. That means the soil particles are very fine, automatically those are also not sufficient. If the particles are very medium, coarse grain, medium grain and fine grain, those three grains we have to observe. Very coarse also not suitable, very fine also not suitable. Only medium grain size particles having a capacity to bind together with the help of this cement and water content. So that we have to choose these medium grain size particles, then only this cement stabilization will be getting strength. Next one, soil. Cement bond material is a hard and durable material. That means it is hard means automatically having good compressive strength. Next one is the durable. Durable means it will bear huge amount of atmospheric challenges like wind, water and other temperature effects. That means durable means if any substance is working against those three conditions, automatically it will be a durable properties. That means the material having durability against those three conditions. The cement hydrates and develops the strength. That means whenever we are hydrating the cement, then only it will get a good quantity of strength. Without hydration, the cement will not form reaction with the surrounding particles, so that we won't get the strength without hydration. Cement stabilization is mostly employed when the compaction process is continuing. That means cement stabilization is mostly employed. That means we have to suggest those cement stabilization. In which conditions means when only compaction is there. Without compaction, this cement stabilization is not working. Why? Because in the previous case we are not stabilized the we are not doing compaction, simply we are mixing the soil profile with the lime content. Why? Because lime having more ionic properties, but in case of cement there is no ionic particles, only reacting particles we are having. So that we need to compact and spray a particular quantity of water on the surface of the earth, then only it will get the strength. As well as mixing is required and compaction required in case of this cement stabilization. But in case of lime stabilization, there is only requirement of mixing process and spreading process. But in case of cement, we have required mixing and compaction, both we have to do, then only we will get a good content of compressive strength. When the cement is added to the soil, fills void between the particles, and then void ratio also it reduces. That means void ratio means number of pore size particles also removed. As cement and soil particles are mixed well with water and added to the soil, cement reacts with water and it goes hard. Normally, we have to observe in our concrete technology lab, whenever we are giving a water to the cement content, automatically, initially for 30 minutes to 60 minutes, it will get a proper shape. After 10 hours, it will be in a good form and gives a huge amount of compressive strength against forces. Likely here also, after reaction is over, the total cement the total cement content whichever is reacted with the soil, those portions will give huge amount of hardness and strength properties, so that unit weight of the soil is increases. Normally unit weight means density. In the previous case, the soil is having only particles without this cement. That means at that case, the density is very less. After mixing the soil with the cement content, automatically density increases as well as strength increases. Both are is in increasing position. Cement in soil with harder and shear strength and bearing capacity also increases. Normally hardness means a good quantity of compressive strength and shear strength. Shear strength means there is no sliding between particle to particle. Why? Because those are closely bonded together, then only they will get a good quantity of compressive strength and shear strength and bearing strength also. That means the total soil will have to bear huge amount of loads compared to previous conditions. That means without stabilization it having less quantity of bearing capacity. After stabilization it is having huge amount of bearing capacity. Plasticity index and workability of the clay soils also will be improves. In fact, that means the cement chemical reactions are not depends upon the soil minerals. The cement chemical reactions are not depends upon the soil minerals, only depends upon the fineness of the particles and reaction time with the water. That means reaction time means whenever we are giving a content of water to the cement, automatically it will absorbs the water and gets the strength and shape. As well as here also what we are getting is the simply we are getting the shape and strength whenever we are mixing with water. This is the primary reason that cement is mostly used in the stabilization of soil any type. That means in which in a few, for few conditions only we have to go for these techniques. Why? Because it is very costlier techniques. One bag of cement is nearly equal to 400 to 450 rupees depending upon its company. That means we are having different companies of cements, KCP, Ultratech, and Sagar Cement and Bharati Cement. Likely we are having different companies. Penna, okay, although they're having different rates compared to according to their chemical properties and reaction times. So that when we goes for the lime, automatically it will be cheap. So that we have to choose those stabilizations wherever they require, in what quantity they require. Why? Because we have to go for, first of all we are have our structure, we have to serviceable, otherwise it is not having too much of strength. What are the advantages using these cement stabilizations? First of all, most commonly used for road construction. That means when we are going to construct a road with rigid pavement, then we have to prefer this cement stabilization. Why? Because normally rigid pavement means CC roads, cement concrete roads. At cement concrete roads, the bottom portion will be very hard. Why? Because the total structure will have to bear huge amount of load in the form of this CC pavement thickness. If the CC pavement thickness is very large, automatically the dead load acting on the soil also very high, so that to bear those dead loads, the structure will having huge amount of bearing capacity, so that this to bear those huge amount of loads, automatically we have to go for this cement stabilization before constructing a CC road in few cases. Next one, heavy clays are difficult to pulverize and not suitable. That means heavy clays are difficult to pulverize. Here pulverization means normally getting a bond between the surrounding particles. But in case of clay soils, heavy clays, normally not light clays, here they mentioning heavy clays. In those particular heavy clays, there is no proper bond between the particle and difficult to get the bond between the particles by different mechanisms. Then we have to go for this cement stabilization. This is suitable in heavy clay conditions. Next one, well graded sand and gravel mixtures with up to 10% fine binder materials like passing zone to sieve. It is another advantage. That means well graded sand and gravel mixtures with up to 10% fine. Fineness means automatically whenever we are taking a 1 kg of material, in those 1 kg of material nearly 100 grams of matter will be very fine. In those cases we will get good quantity of the strength. Why? Because cement have to form with a all particles. Whenever it is possible means automatically if there is a 10% minimum content of 10% is fine, automatically those fine matter will react with the cement, and those two fine matter and the cement matter react with the other size particles. Then only we will get a good quantity of compressive strength and bearing capacity. Next point is quantity of cement to be determined on trial basis in lab. Why? Because cement is having huge amount of cost properties, so that to reduce those cost properties we need to give some quantities of trials. That means for a volume of 1 meter cube, how much amount of cement we have to use, those conditions we need to those conditions we have to find out by simply trial and basis error. That means simply you have to take a particular quantity of matter. For those particular quantity of matter, simply we have to add 1% of cement, and after that 2%, 3%, and up to 10% we have to add. In those particular percentages of matter, at what percentage we are getting good quantity of strength parameters we have to observe. Is it a incremental process or suddenly peak process? That means at a particular point we are getting more strength, after that we are getting same properties, so that we have to observe those percentages variations in laboratories by trial and error method. Then only we will get a good quantity of percentage in the form of cement, and we will reduce the total cost process. That means the total cost of the project. Next, minimum strength required is 3.5 Newton per mm square in the period of 7 days. That means we have to add this cement content to the soil content and with the help of water, and we have to get the strength is 3.5 Newton per mm square in the period of 7 days. That means normally concrete cubes we have to test for 7 days period, 14 days period, and 28 period in the form of curing. That means of 7 days we have to cure the member. After then only we have to go for this we have to go for this testing phenomena. In this particular testing, we have to observe the strength possessed by a member. But in case of here also, we have to go for same like phenomena, and we need to have a minimum strength of 3.5 Newton per mm square. And the next advantage is compaction to be completed within 2 hours after laying and mixing with water. That means within 2 hours. Why? Because cement is having a huge less quantity of setting time, but in a minimum time of period it will sets easily. Why? Because it is having huge amount of ionic particles. Ionic particles means whenever the cement is mixed with the water, within 1 to 2 hours it will totally setting down, so that we have to utilize those period of time, and we have to do compaction and consolidation. Both two conditions we have to do within these 2 hours of span. Otherwise the total material will be in a waste position. That means waste form. We have to reduce those waste conditions. We have to improve those matter in a well graded. In those two methods, how we have to increase the setting time of the cement? Simply here we are having two contents. First one is the central plant method, and second one is the mix in place method. What is the difference between this central plant method and mix in place method? First of all, we have to observe in these terms itself we are having a meaningful knowledge. Central plant means normally nowadays we are observing a huge amount of lorries are traveling for RMC plant to these sites. That means site wherever we are having a construction, so that they are simply transporting the concrete material from RMC plant to construction areas. Likely here also central plant method means in this particular central plant method the total mixing is takes place, and those mixing material will be transported to the sites. In the site itself we have to do these compactions and consolidations, then only we will get the strength. Okay, for faster construction process this central plant method is used. Why? Because we have to get the cement onto the site, and we have to add water, and we have to add some quantity of material, and we need to weigh. All those are simply a huge time taking process. To reduce the time, simply we need to conduct experiments in the lab, and we have to process those values to RMC plants, and RMC plants will directly transfer those contents of materials. Simply we have to use those materials, and we need to lay down the surface. Why? Because if it is a construction expansive dry mix, and then wet thoroughly spreading with and compaction, all those things we have to do in a step by step in a very easy manner without consuming any extra amount of time. Why? Because it is a faster construction. We have to take the material and we have to spread. After that we have to go for consolidation, expansive dry mix, then wet thoroughly. That means we have to take all those materials in a dry mix, expansive dry mix only. Why? Because if we add water, automatically those will be setting in a easy manner. That means if the distance between RMC plant and our site is very less, automatically the cement will be setting takes place. So that to reduce those, we are not adding water in the site itself, we are adding a water. That means wet thoroughly means automatically we are getting water onto the top surfaces, then spreading and compaction takes place. The mix in place means automatically similar to agricultural rotary cultivator. Normally in our agricultural fields we have to observe these rotary cultivators. Simply whenever we are giving water content and field compactions, that means in the starting of harvesting of a crops, we have to go for these agricultural cultivators, so that they will smooth down the total surface of the land. Then only we have to draw down lines, and then after that lines is over, we have to go for planting the trees, the small plants of different crops. Here also simply we have to cultivate. First soil is be supervised, soil is pulverized. That means the soil we have to observe the what which content we are having, and then we have to dry with the cement. That means the dried cement will be added to the soil and spreaded over the soil content, and the total soil and cement both we have to spread in a equilateral manner, and then water we have to sprinkle on the layers. That means the total soil and cement ratio we have to mix in layer by layer. After that we have to go for watering technique. Again the remixer and shape to a camber and compacted using these rollers. That means whenever we are giving this mix in place method, we have to go for different step by step process. In the first step we have to go for spreading of cement. In the next step we have to go for mixing of those cement and surrounding soil particles. In the third step we have to go for this remix and shaping. In the fourth step we have to go for compaction with the help of these rollers. These are the four mix procedures we are using in mix in place method. But in case of central plant method, the total soil cement mass is taking, and those mass will be spreading. After the spreading is over, simply we are pouring or spreading the water. This is the difference between the central plant method and mix in place method. Next one, different contents, normal soil cement and plastic soil cement. That means there may be difference in the purpose of strength criteria. First of all we have to observe what is normal soil cement. It consists of a 5 to 14% of cement by volume. That means if you are taking a 1 meter cube of soil, in those 1 meter cube of soil we have to use only 5 to 14% of the cement, and cement is sufficient to produce a hard and durable material. That means normally cement is sufficient, means it will be enough to produce hard and durable materials compared to other stabilizations. Next, third thing is sufficient water we have to use for hydration requirements and workability properties. That means we don't have to go for huge amount of water, and we won't have to go for less quantity of water. We have to give a sufficient quantity. We need to observe the sufficient quantity of water whenever we are doing this trial and error methods in laboratory. For 1% of cement, how much amount of water we have to require? Likely we have to do some quantities of investigations, or in case we have to observe different publications related to this soil stabilization techniques. By those we have to take the values. It is weather resistant and strong, and used for stabilizing sandy and other low plasticity soils. That means it is weather resistant. That means whenever there is a rainy season, whenever there is a snow season, automatically all those weathers can be resisted by these soil cement stabilizations, and it is very strong in those particular times. It is used for a stabilizing of sandy and other low plasticity soils. Why? Because sandy soils having huge amount of particles with high particle sizes and voids, so that definitely for stabilizing sandy soils we are using these cement stabilizations. Next method is plastic soil cement. It consists of same 5 to 14% of cement by volume. It has more water to have. That means why? Because in the previous case we are using only appropriate content, a sufficient content, but in case of plastic soil cement we are using more water we have to go. Then only we will get this plastering motor as to time to replacement. That means whenever we are using more amount of water, automatically we have to form a slurry like material. That means a cement slurry, all you know. Likely here also whenever using more quantity of water, automatically this cement and surrounding particles will form as a slurry, and those slurry we have to adjust and place within the time period, and used for waterproof linings of canals and reservoirs. That means canals and reservoirs as a waterproofing material. That means Normally the purpose of canals and reservoirs is to store the water and transfer the water. Canals normally using for transferring water from high water level to low water level areas. But in case of reservoirs, normally reservoirs having capacity of storing water. Those two structures we have to construct with the help of this plastic soil cement to retain water above the structure. Why? Because if we are simply constructing or if we are simply storing the water, automatically all those water will be penetrating into the subsurfaces and stored as a groundwater. There will be no water on the top layers. To arrest those penetration techniques, simply we have to give some soil cement lining to the canals and reservoirs. Then simply they will restore the then they will store the water for a long period of time. Used for protection of steep slopes against water erosion. That means whenever the water is moving from one point to another point, automatically the water particles will carry the soil particles along with them. Those phenomena we are calling as a erosion. But in case of canals and reservoirs, this erosion phenomena is very high, especially in rainy seasons. To arrest those erosion phenomena, simply what we have to do is we need to give a lining to these canals to control the erosion due to water. This is the another phenomena. That means here we are simply here in the previous case we are observing a dry mix plant and in situ plant. That means in the dry mixing plant means automatically from the plant we are taking the material and those material we have to spread in the soil. Here they are also simply doing the process. The blades will simply spreading the total content of cement particles on the layers of the soil. After that previous we are spreading the cement head of the machine. Okay, this is the total process we have to observe. First of all, we are using a different techniques. For what we are having is hose connection to the water tanker. That means we have to give some quantity of water and we need to fix those. After that microprocessor controlled pump for spraying water and spreading cement ahead of the machine and working direction. In the initial condition, what we have to do is we need to spread the cement on the layer of the land and then we have to mix. That means here we are having a rotation symbol and arrow direction. That means on that particular arrow direction the machine is moving. Against this arrow direction we are having rotation symbol. That means the blades are moving and then the total material is mixed with the cement content. And then we have to what we have to do is on the another hand we are having spreading of water. After mixing is over, simply the mixed portion is we have to do wetting phenomena. Due to this wetting phenomena, automatically the total water is sprayed on the surface of the land and then that we are getting huge amount of strength within the time period of 2 to 3 hours. This is the total procedure how we have to do this mixing phenomena in the site conditions. This is also another technique where what we have to use means simply it is a slope areas. That means in this particular areas we have to observe a slopey stand is there, automatically a particular quantity of soil also there. In this particular lands we have to do this soil cement stabilization. Why? Because to prevent erosion of soil. Once again we have to observe all those points. Soil stabilization, how we have to do these soil cement stabilizations. And we have to compare those advantages and disadvantages of this lime stabilization and soil stabilization. In this particular lime stabilization, we are not using a content of water. Simply we are spreading the lime against these soil layers and we are well mixed. After that we are simply consolidation. This is also the same process, but in case of soil cement stabilization, simply we are using a water content and equipment also very high. In the previous lime content we are simply a spreading roller is there. The total spreading roller is moving on the surface of the ground. Automatically those spreading roller will taking all the lime content to the soil in a equilateral manner. That means equi process they are moving the lime to the soil. But in case of here, a equipment is simply grinding the total cement content and this soil content. They will form as a paste, and after the paste is simply settling on the another side. Those for those paste simply we are adding some content of water, and then the total mix is setting within the time period. This is the basic difference between lime stabilization and cement stabilization. In the lime stabilization, what we are doing is simply we are spreading and mixing the sample, and after that a rolling is necessary. But in case of here, spreading, mixing and rolling and then watering also there. Simply we are doing a slope stabilization here. We have to observe a greenery content is there on the soil. Below the mass we are doing a particular lining mechanism. On those lining mechanism we are having a soil of very fine particles, not so fine particles, some medium particles are there. For those medium particles we have to add some content of cement, and then we need to do this stabilization. Okay, in the next class we have to discuss the chemical stabilization.